So in Mulesoft, we have many like core components. Okay, you should know what component what all component we have and in which scenario we should use which component. Okay, so we will have some discussion on scenario also, not today. Scenario wise discussion we will do in next session, but today we will understand first all the component. Okay, and tomorrow we will have some scenario based and we will discuss what component will be more suitable. Okay, so for transformation, we have remove variable, set variable, and set payload. Okay, so this set variable we use to create variable, set payload we use to create payload, and remove variable will use to remove the variable. Okay, so all this part is a transformer. Okay, then inside scope. Okay, inside scope we have multiple kind of scope in Mulesoft. Okay, and this one is like you should have very good understanding. First is async scope. Okay, so first, like whenever you want to do any processing for any component or set of operation in asynchronous way. Okay, then we should use this async component. Sorry. Let's say you have one API, you are developing one API where you want to do some processing, and after that or in between you want to send email notification or SMS notification. Okay, that is part of your functionality, but that is not that functionality. Even if that functionality will fail, it will not impact your business. And even if that functionality will process asynchronously, like it should not be like once that functionality will be completed, then only you will able to send success response. Even if that functionality is in progress, execution in progress, you will able to reply successfully to your customer or your from where you are getting request, you will able to reply. In that case, we should use this async component, and inside this async component will do all the required processing. Okay, next cache. Okay, so in Mulesoft, like caching is like this particular component is very much important component to increase the performance and capability of your API. So caching we can do on two level of in Mulesoft. One is on application level within the application, and another one is on gateway level. Okay, so gateway level caching we will discuss when we will discuss about security policy. And this cache component, when we are doing caching on component level, then we use this cache component. Okay, so what this cache component will do, whatever business logic you will define inside this cache component. So for first time when it will receive request, so you need to define what will be your key to identify the cache. Okay, so you need to define some key. So once you will make request to this cache component, and it will what it will do, it will check the key and it will check the related value in their cache store. Okay, if it will get the key value pair in that cache store, it will retrieve the value from there and it will give the response from there. And if this key is not exist there in their store, then what it will do, it will do the actual processing of component. And then once the processing is done, that key value pair will be stored inside cache store, and then it will give the result of that cache component. Okay, let's try to understand through this diagram. So here we have this Mule application where we have this component, and then we have this cache component. Okay. Now inside this cache component, we have three component. Okay, component C1. Say this one is C1, C2, C3, C4, C5, C6. Okay. So whenever request will come here, it will come to C1, it will go to C2, and then this is our cache component. So once C2 will call this, like this will go to this cache component. So first cache will check whatever key it has defined. Okay, that key is stored in their storage or not, key value pair. So based on that key, it will check that key value pair exists in their storage or not, cache storage or not. So if that exists, means that will be considered as cache hit. Okay, in cache we have two component, cache hit and cache miss. Okay, if that value is available in their storage, that means there is a cache hit. So it will take value from their storage and it will go to next component. It will not do processing of 3, 4, 5. It will go to directly 6. But if there will be cache miss, then what it will do? It will call the 3, it will call the 4, it will call the 5. And once it will get the final response of this particular execution, what it will do? It will store that key value pair in their storage, and then it will go for C6. Okay. Next time, if same key will come, then we will get value from storage. We don't need to do processing of these three again. Okay. So this particular concept is known as this particular component is known as cache component. And generally, why we use this cache component? When like we are getting static response from here after execution of C3, C4, and C5, whatever response we are getting, that response is not changing very frequently. Okay, let's say the overall response of after this processing will change maybe like once in a day or maybe after 10 minutes, 20 minutes. Then let's say this particular execution is taking 2 seconds, and in 1 hour we are getting, or let's say in 1 minute we are getting 100 requests. So 100 into 2 seconds, like 200 seconds it's taking here. But if we will do caching, then it will take 100 milliseconds. Okay, almost 1 by 20 time lesser. Okay, so what we can do, like in 100 transaction also, we are saving almost 1 by 20 like time of previous 200 by 20, almost 10 seconds. So previously it was taking 200 seconds. Now it's taking only 20 seconds to process all those record here. Okay, so definitely it will improve the performance of our API. So we should do caching whenever we are calling any, whenever we are doing any logic, means we are applying any business logic, and we see that like response of that particular business logic will be static for some particular duration. Then we can store, we can configure those inside cache component. Okay, and here we need to define like how much time that cache will be stored in our storage. So if this response will be static for 10 minutes, then you should do caching for 5 minutes or around 5 minutes only. You should not do caching for 10 minutes or 20 minutes. Since like customer also want to get real-time data. Okay, so if caching is for 10 minutes, then we like that static response is for 10 minutes, we should do caching for 5 minutes. Okay, so that customer will not have like any data discrepancy. Hope everyone clear with this cache component. Next, flow. Everyone know like in Mulesoft we have three component. One is flow,
Uh,
another one is
uh,
subflow.
Ravi, do you have any example for catchy flow? Do you have any example?
Just now we discussed, no, when we took one scenario only. No?
No, 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 no. Yeah, that is okay. Any, I mean, in the flow level, do you have any example? Flow level.
Okay, real time example you want to get, you want to know.
Yes, yes, yes. Yeah.
Okay, okay, fine. So let's say we are calling any here we are calling one third party system to get the flight schedule. Okay, so we are integrating with any like this is a application to book a to do a reservation of flight. Okay, or to book a reservation of hotels. Okay, so here we are calling that let's say this is Make My Trip API, Make My Trip company. So they have tie up with many hotel company or restaurant or like hotel or flight company. And here I want to retrieve all the hotels in that particular area. Okay, with their available seats. Okay, so you know like that the number of seat will not change very frequently. That reservation will happen like once in an hour or twice in an hour. Okay, that reservation number of available seats will not change very frequently. And for example, we are getting 100 requests or 1,000 requests in 10 minutes. So if every time we are calling that like third party hotel database or something from where we are getting detail or their API from where we are getting detail. So what will happen? Your API performance will be slow. Instead of that, you can cache the detail, okay, and you can retrieve detail from there. Let's say I want to get how many number of hotels we have. Okay, so Make My Trip want to display. So for one customer is there, he want to see what all available hotels we have in that particular area. Okay, so do you think like that company will keep adding hotels on every 1 minute or 2 minute? New
Hmm.
hotels will come once in a day or twice in a day. New hotel registration will happen. Okay,
Hmm.
so what this Make My Trip will do, instead of calling all the hotels API or from where they are getting hotel detail, that external system, it can be database or something. Instead of calling that external system, it will take data from cache. If it will call the actual system, it will take 3 seconds. And Make My Trip has thousands customer, active customer. If all will make request in a minute, then 1,000 into 3 means 3,000 seconds it's taking to serve that request for this part only. Instead of that, it will if it will use caching, then it will be served within 100 seconds. All the requests will be served in 100 seconds. Since you know like number of hotel will not change very frequently. So we can do caching for half 1 hour, 2 hour or 24 hour. Is it clear now?
Yes, yes, yes.
Then flow. So, okay, in MuleSoft, we have flow, subflow, and private flow. Okay. So all these have some okay, let's discuss in Notepad. So in MuleSoft, we have flow, we have private flow, and we have subflow. And anyone know like what about these three? Flow, subflow, and private flow?
Like Raveen, flow will be defining all the flow of execution. In private flow, will be calling another flow. Subflow will be calling another subflow, and private flow will be for the private flows with error executions.
Okay. Anyone else?
I didn't get your question first of all,
Yeah.
Ravi.
Can you define this? Anyone can define this? What is flow, subflow, and private flow?
Yeah, okay. Yeah, flow is nothing but a general flow. We can add the source system and target system. We can maintain in that. And a private flow, it can call it as asynchronous flow, and it contains only it contains uh, s- uh, it contains only I mean it's not containing the source system. Uh, it will follow the asynchronous way. We can follow it in private flow. We cannot expect the target from the private flow. And subflow, it contains a synchronous way it following it. It contains the uh, it contains the source system and the target, both we can maintain in the subflow.
Okay. Okay. It's partially correct. Okay. So whenever we discuss about flow, subflow, and private flow, we discuss about three things. One is source, second processor, and third error, and four reusability. Okay. So whenever we discuss about this four thing, means flow, subflow, and private flow, we discuss about four things. Okay. So one by one we'll discuss. So first of all, flow. Flow will contain source, yes. It will have processor, yes. It will contain error handling, yes. It will have reusability. Since this, like whenever it contains source also, like whenever request will come to source. Since it contains request will come to flow since it contains source or trigger point. Okay. So this particular flow, ideally, we should not like we don't use in other places. It's an entry point of our execution. Okay, so it will contain source, which is entry point or trigger point. It contains processor where we apply all the business logic. It contains its own error handling. Okay, and reusability, it will not have reusability since it will have trigger point, means from where API processing will start. Coming to private flow, source, no, it doesn't have source. Processor, yes. Error handling, yes. Reusability, yes. So private flow actually, if you will say technically, private flow doesn't exist. It's just a concept. Okay. Actually, flow can be treated as private flow if it will not contain. We don't define any source. If we source part as a empty, then that flow is known as private flow. Okay. And why we need private flow? For example, we want to define some reusable flow which can be used at multiple places. Then you will say we have subflow also where we can put reusable components which can be used by multiple flow. But in subflow, we don't have error handling. That's why if we want to define any reusable components or reusable business logic which need its own error handling, then we use this private flow. Okay. And coming to subflow, it doesn't have source. It has processor. It doesn't have its own error handling. And the main purpose of creating of this subflow is reusability. If we have some reusable business logic which can be used by multiple flow, then we define inside subflow. Then we like put that reusable logic in subflow and can be used by multiple flows, private flow. Is it clear to everyone?
Yes, yes, yes.
Ravi?
So yes.
Yeah, threading level also some difference is there. Can you clarify on threading level difference between these three?
Trading level, don't think any difference. Trading is different concept which work on component level, which doesn't work on flow, private flow, and subflow level.
Okay.
Okay. Threading concept works on component level, like we have multiple kinds of thread. Okay. Based on the component, which thread will be in, like start its execution, that will be decided. Okay. Anyhow, we have one separate class, like one full day discussion for Mulesoft trading. Then we will
Okay.
discuss, but threading level, I don't think any difference we have.
Okay.
Okay. So hope everyone clear with this flow, private flow, and subflow. And this will be one of the favorite interview question you will get during your interview. Okay. And if you want to see on studio, so this is the flow where we have source, we have processor, and we have error handling. Okay. If it will contain only processor and it has error handling, but it doesn't has source, then it will be private flow. And for subflow, you can see here it doesn't has its own error handling also, and it doesn't has its source, only processor. Okay, you can put any component here. Only it has processor. And which component we use to connect between this flow, subflow, and private flow? That is flow reference. Okay, so we use this flow reference to make communication in between those flow, private flow, and subflow. Now, can anyone tell me if I want? So here you can see it has its own error handling. It has its own error handling. But in subflow, we don't have any error handling. And we have requirement for few components in subflow. I want to do error handling on component level. Then how we can do that? Anyone can tell me?
Try scope we can use.
Yes. So for that, we have try scope. Okay. And you can see here in this try scope, we have this error handling. Okay. If I want to do error handling on component level or within subflow for few component, then we can use try block. If there will be any error, it will go to this error handling. Okay, everyone clear with this? Okay, fine. So next. Now we have for each and parallel for each. Okay. So for each and parallel for each, we have two component. First, like for each, whenever we have an array, everyone go on mute. If you are not speaking, please go on mute. Ravi, please go on mute. So whenever like we have a list of element or we have array as our input, and we want to do same processing for each element of array. Okay, so in that case, we can use for each component where input will be list or input will be array, and it will iterate on each element of array one by one. Okay, and at the same time, that's for each, like for each component, each synchronous calling, like first it will process first record, then it will go for second, then it will go for third. Okay, but if we have requirement, we want like it's taking too much time and we want to do it asynchronously, like we want to do parallelly, then we will use parallel for each. So that parallel for each will be multi-threaded. So this for each will be single threaded, but parallel for each will be multi-threaded, means we are doing parallel execution. How come it's possible? It's possible with the help of multi-thread. Okay. Try block, just now we discussed, like if we want to do error handling on component level, then we use this try block. And until successful. This component we use whenever we want to do any processing and we want to retry for that particular processing if due to any reason it failed. Okay, let's say we are calling any API or we are calling any connector, okay, which doesn't support retry. Let's say there are a few connector which doesn't support retry. So what we can do, we can put that particular component or connector within this until successful. And here you can configure maximum retry, how many time you want to retry. If it will fail, then how many time you want to retry, and what will be duration. Duration in millisecond means 1000 millisecond equals to 1 second. So how many time you want to retry, that we define here. Okay, so this until successful component will help us to retry if some component is failing and like we should not processing or we need to retry as per our business requirement, that particular processing is very important and we can't initiate the process from very beginning. So we can use this particular component to retry. Still after that particular retry it will fail, then it will fail, then we can't do anything. Okay, after this we have flow control, which is very important. So we have choice, first successful, round robin, scatter gather. In choice we will have multiple branch. Okay, this is the so let's discuss first one. Okay, choice one. So here we will have some condition. Here also we will have some condition, and here we will have default one. Okay, if this condition will match, it will go to this branch. Okay, this is branch one. This is branch two. And this is branch three. Okay, if condition will match, it will go to branch one. If condition will not match, then it will check this condition. And if it will match, it will go to branch two. Okay. And if this condition will not also match, then it will go to default one. There must be one default. Otherwise, it will give you error. Okay. So this will be in case of choice. Second, we have first successful. In first successful, what we will have multiple branch. So it will go to first branch, that execution is successful or not. If yes, then done. If not successful, then it will try for second branch. If this is successful, then done. If not done, it will try for third branch. If it is this branch is executed successful. If yes, then good. If no, then this component will give you error. Okay, so what it will do, it will try for each branch. Is one by one, it will try until like one branch will not be successful. If all the branch will fail, then that component will be in error. Round robin. In round robin, let's say we got one first request, it will go to branch one. Second request, it will go to branch 2. Third request, it will go to branch 3. Fourth request, it will go to branch 1. Fifth request, it will go to branch 2. In this way, in round robin way, request will keep going to different branch. And scatter gather. In scatter gather, whatever request will come, it will go to all 3 branch. Okay. And can anyone tell me why, when or why we need this scatter gather? So this component is very widely used. So
For
Uh,
rollback purpose, if any one of
rollback.
the block is failed, so the total all the 3 blocks should be rolled back. The process should be rolled back.
Not correct one. Anyone else want to try?
if you want to run multiple files, we want to work on same task, we need to run same time, then we can use scatter gather.
Sorry, multiple.
If we have a single requirement, we have to run a multiple file. For example, the same file we need to run JSON XML file. Same time, if we run it, we can use scatter gather. Multiple time, I mean, like single time you can run all the files and multiple ways.
Partially correct. Anyone else want to try?
Like Ravi, when we want to send single message to all the resources, then we'll be using scatter gather.
This is also partially correct. This is correct, but not like defining the complete use case of scatter gather. Okay, let's say I'm getting request here, and we have one target system. Okay, to like call the target system, we need different set of data, which we will get different end system. Let's say here I am getting customer information. Like I want to retrieve customer information, I want to retrieve account information, I want to retrieve payment information. And then I need to call one target system to store all those information. Okay, so for same customer, I want to retrieve all this information. And if you see here, like account information, I want from account table, customer information, I want from customer table, payment information, I want from payment table or transaction table. And for all the 3 requests, we need customer ID, which we got as a request of our API. So all these 3 API, all these 3 business logic where we are retrieving all these 3 kind of data, all of those are independent of each other. Okay, one way we can do sequential call. First we will call to get account details. Second we will call to get transaction detail, and third we will call to get customer detail. Okay, and it's, let's say each are taking 3 seconds, 2 seconds, and 5 seconds. So total will be 5, 3, 2, 10 seconds. But here they don't have dependency on each other. They like we can call them independently. Okay, so what we can do, we can use scatter gather and we can create 3 branch. And in each branch, we will do that particular processing. Here we are calling customer information, which takes 5 seconds. Here we are calling account detail, which takes 2 seconds. And here we are calling transaction detail, which takes 3 seconds. Okay, so if we do sequential call, then it will take 5, 3, 5 to 7, 3, 10 seconds. But if we are doing parallel processing, then in 5 seconds, this will be completed. This will be completed within 5 seconds. This will be completed within 5 seconds. So overall processing is 5 seconds. Okay, and all of these are independent of each other. So we are capable to do this parallel processing. So if we have this kind of requirement where execution, like all the business logic, what we are doing, they are independent of each other. They are independent of each other, and like we can execute them in parallel. So we should use scatter gather. So it will make our API more efficient and our processing time will be less. So in this kind of scenario, we should use scatter gather. So whatever event like mule event will come, that mule event will be passed to all three branches in scatter gather. And once it will complete the processing, it will return payload array. Okay, so there will be one payload which contains array. Within that array, all three payload will be there. Okay, if you want to retrieve the payload from here, what will be overall response of this branch? Then syntax will be so let's say I want to get the payload, my like response of this particular branch after processing. What is the payload? So syntax will be payload dot zero dot payload. Same way, if I want to get data from second branch, payload dot on dot payload. Okay, and for second it will be like third branch, it will be payload dot payload. Okay, this will be like syntax to get the payload from this scatter gather. And if you pass only single payload, then it will give you combined response of this scatter gather. Okay. Now we have error handling component. So this error handling component, we have error handler, on error continue, on error propagate, and rage error. Okay, so this error handler like this is the block which contains error handling component. This is like you can say it's a kind of flow which contains error handling component. On error continue, this component will catch the error and it will send you success response. Whenever there will be error in flow, this component will catch that error and it will send you success response. And by default, it will send 200 status code. On error propagate, this component will catch the error and it will send you error response. And by default, error response will be 500. And if you want to create any business error, let's say there is some API where if customer age will be more than 18 years, we need to raise a business error. Technically, if customer age is 18 years, more than 18 years, or sorry, less than 18 years, so there should not be any problem. Data wise, it's okay. Like data can be 18, 15, whatever. So technically it will not fail. But if you want to create raise a error, if you want to create error, so those kind of error known as business error means as per business requirement, we are creating error. So at that time, we will use this raise error component. Now we have endpoint. So we have one scheduler endpoint. So this scheduler component we use whenever we want to run our Mule application on like either on fixed interval or any specific schedule time, then we use this scheduler component. Okay. So here in fixed frequency, we need to define time and we need to give unit, which unit we want to use as a fixed frequency. And in another way, we can write cron expression. Okay. Based on the cron expression, it will run to that particular time. Okay. So these two like we'll take tomorrow. Okay, it's already like late for us. Since batch processing itself will take 15 to 20 minutes in explanation. So let's do it tomorrow. Okay. So I think we are done for today. Let me know if any doubt. Otherwise, we are good to close our today's session. And as I mentioned, like this initial 2-3 day, we will cover basic things and slowly we will go for complexity. Around like 15 to 20 session we will have. Okay. And we'll go on like integration architect wise. We will try to discuss all the concepts. Okay. Like we will have some advanced concept also in future, like what is related to load balancer Then security policy also we will discuss in detail, like what all security policy we have, on which layer we should apply which security policy, what is the advantage, disadvantage of applying those policies, in which use case we will apply. So not only for security policy, for everything we will have use case and all. So component wise use case, like we will discuss tomorrow, since we have to cover this component first, and where batch processing itself is a very big topic which will take some time. So let's discuss tomorrow, and then we will discuss some scenario based thing, and we will see which component will be suitable on those particular scenario. So which will give you more understanding, like on component level, how you will choose which component will be suitable for which API development. Okay, fine. Thanks for today. Let's connect tomorrow.
Ravi. Thank you, Ravi.
Yeah. Yeah, and if any one of your friend want to register for this training program, yeah, you can like you can ask them. Still, they have chance. They can register for this training program. Once 3-4 day will be completed, then for them it will be difficult. Okay.
Sure, Ravi, sure.
Yeah, and timing wise also, like it will be fixed time, so no need to discuss on daily basis. Like every Saturday and Sunday, IST time will be 8 to 10, and EST time, like that is US time, that will be 10:30 p.m. to 12:30 p.m. 12:30 a.m. But IST time will be 8 a.m. to 10 a.m. It's like till next 20 session we will have same time. If there will be any small change, I will let you in group. But if I'm mentioning in group, then means we will go on schedule time only. Okay. And for one more thing, like soon I will ask for email access. Oh, sorry. Soon I will ask you to fill one Google form. Okay. So in that form, I will ask your email address and other detail. Okay. Based on the email address, I will give you Git access. Okay. In that Git, you will get all this document, and same email ID I will use to give you video access. So for 2-3 class, video will be public. Okay. But after that, after 3 class, like all video will be private video. So you will able to access those video using that email ID. Okay. So you
Sure.
must need to log in your YouTube with the same email ID to access those video. Okay, fine then. I will ask to fill that Google form maybe next Monday. Okay, I will give you in our WhatsApp group what we have created, private WhatsApp group. Now. There I will share. Okay, and meanwhile, if anyone has any doubt, any kind of doubt, you can ask in our private group. So I will try to answer those questions in group. Let's say you are doing recap of any session, and if you are having some doubt, instead of waiting for next week, you can ask in that group anytime. Okay, fine then. We are good with today. Let's connect tomorrow. Thanks everyone. Bye.
Thank you, Ravi. And tomorrow we have a class, right?
Just now I mentioned no need to ask until unless I will not inform in group.
Okay,
So
okay.
we will have on schedule time Saturday, Sunday, that mentioned time we will have. If there will be any change, 90% time there will not be any change. If there will be any change, I will update in group. If no update, means we will be on schedule time only. Okay, and same thing we'll have for next 20 session. Okay. Okay, fine then. Thanks everyone.
Thank you.